Hello everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11th here. That is your class 24, which we had started with, and we had done your 23rd class in the last sessions, and the unit for that will be continuing as your unit 3, which is motion in a straight line. So in motion in a straight line, we cover up that. So motion in a straight line here, that we'll first discuss the table about the physical quantity, symbol, dimensions, unit and remarks. So for the same, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So before that, I will just tell you some points that you have understood and you have to remember in this particular unit. Then we'll discuss the table as well. So that the path length that traversed by an object between the 2 points is in general now at the same as magnitude of displacement. The displacement depends only on the endpoints, and that the path length, as the name implies, that depends on the actual path. In one dimension, the two quantities are equal only if the object does not change and its direction during the course of motion. In all other cases, the path length is greater than the magnitude of displacement. Where in the same way, in a view of point 1 above, that the average speed of an object is greater than or equals to the magnitude of the average velocity over a given time interval, where the two are equal only and if the path length is equal to the magnitude of displacement as well. The another is that the origin and the positive directions of an axis are the matters of choice. You should first specify this choice before you assign signs to quantities like displacement, velocities and acceleration. If the particle is speeding up, acceleration in the direction of velocity. If its speed is in decreasing, acceleration is in the direction opposite to that of the velocity. And this statement is independent of the choice of the origin and the your axis here. In the same way, the sign of the acceleration does not tell us whether the particle's speed is increasing or the decreasing. The sign of acceleration as measured in point here, that depends on the choice of the positive direction of this axis. For example, if the vertically upward direction is chosen to be the positive direction of the axis, the acceleration due to the gravity is negative. If the particle is falling under the gravity, this acceleration, though negative, results in increasing speed. For a particle thrown upward, that the same negative acceleration of gravity results in decrease in speed here. The zero velocity of a particle or at any instant does not necessarily imply zero acceleration at that instant, and a particle may be momentarily at rest and yet have non-zero acceleration. For example, a particle thrown up has zero velocity at its uppermost point, but the acceleration at that instant continues to be the acceleration due to gravity. And the same way, in the kinematic equations of motion, the various quantities are algebraic, that is, they may be positive or negative. The equations are applicable in all situations for one-dimensional motion with constant acceleration, that is, provided the values of the different quantities that are substituted in the equation with proper sign. The definition of instantaneous velocity and the acceleration that are exact and are always correct, while the kinematic equations that are the first true only for motions in which the magnitude and the direction of accelerations are constant during the course of motion here. So now we discuss for the another one that has been the important one here too. So we go for it. So on the same way here, we'll discuss the rest, table, and then we'll discuss the rest of the questions here. So here for the physical quantity, this is symbol, dimension, unit, remarks. So here physical quantity, then we have your symbols, dimensions, then unit, and of course then remark. So on physical quantity here that we discussed, which is all about path length here. For the path length, no symbol, dimension is length, and remark, no remark. Displacement, for displacement, symbol is delta x, this is L, this is in meter, unit is also meter here, and here it is x2 minus x1, which is in one dimension. Its sign indicates the direction here. Now we go for another one, which is your velocity. So for velocity, we have average velocity and instantaneous velocity. So no symbol will be representing for first one, that is your average, and the second is your instantaneous. So for velocity, no symbol will be representing here, just LT inverse, unit is meter second inverse. Now for average, the sign is V bar, and this is your delta x by delta t. Now for instantaneous, it is been V, it is the same, and here it is limit delta t equals to 0, delta x by delta t equals to dx by dt. So in one direction dimensions, its sign indicate the directions here. Now we go for another one, which is another important question, and that we have here. So for that, it will be speed. We talk about for speed for the physical quantity. Speed, the symbols we don't have, and it is LT inverse. This is meter second inverse. So for speed, there is average speed, and the second is instantaneous speed. For average speed, it will be, remark is path length upon time interval, and for instantaneous, it has been dx by dt. So for acceleration, here it will be LT inverse square, which is meter second inverse square. So here first we'll be having average, and the second we have your instantaneous. So for average it will be A bar delta V by delta T. This is A, so here it will be limit delta T tends to 0 dV by d delta T equals to dV by dt. So here in one dimension its signs indicates the directions here. So for that, so for the same we'll be going for the another one, and we'll discuss the rest question. That what I had told you about, that we'll discuss in the motion in a straight line. So that first question for the given box we had discussed about it. So we'll discuss the second question here. So the position time xt graph for two children A and B returning from their school O to their home P and Q respectively, that will be shown. You have to choose the correct here and entities in the brackets below. The first one is A by B lives closer to the school than B by A, where A by B starts from the school earlier than B by A, and A by B walks faster than B by A, and A and B reach home at the same and different time, same by different time, and A by B overtakes B by A on the road once or twice. Yeah, so that was the question second. Now we discuss about the third question that we will be dealing here. So on the same way, there will be graph on that from O to A in a way and a B, then it will be intersecting each other, and you will be have to find it out for the same. So I just write it down for the second question, the graph that we have here. So it will be, this is T, P, this is Q, and this is for X, A, and this is B. Okay, so for the same, the third question we'll talk about it here. A woman starts from her home at 9 a.m., walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away, stay at the office up to 5 p.m. and returns home by an auto with a speed of 25 km per hour. Choose suitable scales and plot the xt graph of her motion. The fourth question we have for this: a drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed again by the 5 steps forward and 3 steps backward, and so on. Each step in 1 meter long and requires 1 second. Plot the xt graph of his motion. Determine graphically and otherwise how long the drunkard takes to fall a pit 13 meters away from the start here. Another fifth question we have here for the same, it will be that a jet airplane traveling at the speed of 500 km per hour that ejects its product here, and of combustion at the speed of 1500 km per hour inverse per hour, and that related to the jet plane, what is the speed of the latter with respect to an observer on the ground. Another we have the sixth question is that two trains A and B of length 400 meter each are moving on the parallel track with a uniform speed of 72 km per hour in the same direction, with A ahead of B. The driver of B decides to overtake A and accelerate by 1 meter second inverse square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? The sixth question we have, on a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite direction with a speed of 54 km per hour each. At the certain instance, when the distance AB is equals to AC, both being 1 kilometer, and B decide to overtake A before C does, what minimum acceleration of car B is required to avoid an accident? Another question is, two towns A and B are connected by regular bus services with a bus leading to either direction every T minute. Here, a man cycling with a speed of 20 km per hour in the direction of A to B notices that a bus goes past him every 80 minutes in a directions of his motion and every 6 minutes in the opposite direction. What is the period T of the bus service and with what speed that assume constant? Do not buses apply on the road here? Another one we have here is the 10th question. A player throws a ball upward with an initial speed of 29.4 meter second inverse. Here, the one we have, what is the direction of acceleration during the upward motion of the ball? The second is, what are the velocities and the acceleration of a ball at the highest point of the motion? Third is, choose the x equals to 0 meter and t equals to 0 second to be the location and the time of the ball and its highest point vertically downward direction to be the positive direction of x-axis, and give the sign of the position, velocity and acceleration of the ball during its upward and downward motion. The D is, to what height does the ball rise and after how long does the ball returns to the player's hand, where G equals to 9.8 meter second inverse square and neglect the air resistance. Now we talk about for the 11th question here as well. So for the same we go for it, and that is the 11th question here. You have to read each statement below carefully and state with the reason here, and that is true false. So a particle is one dimensional, we have motions here. So another is that with zero speed at an instant that may have non-zero acceleration at that instant. With zero speed may have non-zero velocity. With zero speed may have non-zero velocity, as well as with constant speed that must have zero acceleration, with a positive value of acceleration that must be speeding up. And another 12th question is that a ball is dropped from a height of 90 meter on the floor. At each collision with the floor, the ball loses 1/3 of the speed. You have to plot the speed time graph of its motion between t equals to 0 to 12 seconds. The 13th question is, explain clearly with examples the distinctions between. The first is, to magnitude of the displacement, sometimes called distances, over an interval of time, and the total length of the path covered by a particle over the same interval here. Another B1 is, to magnitude of the average velocity over an interval of time and the average speed over the same interval, that is the average speed of a particle over an interval of time, is defined as the total path length divided by the time interval. Show in a both here, that is which we'll have to discuss, A and B, that is the second quantity is either greater than or equal to the first when the equally assigned true. So for simplicity, consider one-dimensional motion only. The another 14th question we have, a man walks a straight road from his home to the market 2.5 km away with the speed of 5 km per hour. Finding the market closed, be instantly turns and walks back home with the speed of 7.5 km per hour. What is the magnitude of the average velocity? Average speed of the man over the interval of time 0 to 30 and 0 to 50, 0 to 40. You will be appreciate from the exercise why is better to define average speed of a total path length that is divided by the time and as magnitude of average velocity here. The 15th question we talk about it, that has been in this question we'll be finding it out. We have a carefully distinguishment between an average speed and a magnitude of average velocity. No such distinctions is necessary when they consider the instantaneous speed and magnitude of velocity, and the instantaneous speed is always equals to the magnitude of instantaneous velocity here. Why? Now another question we'll be having is here the 16th one, which is look at the graphs A and B that carefully with the react which these cannot be possible to represent the one dimension of a particle. So the graph we have as follows. For the A one, the first graph we have, this is on X. This is for with respect to time T. So from here to here, coming from here to here. This is the A1. Another one is V respect T. So for that, here, this is B. So for C, speed with respect to time. So for that it will be and then we have with respect to time total path length. Here for the same. So these were all that what we'll have to go for it. Now we go for the another question here, that has been the another important one. So for that it will be in figure that shows the xt plot on the one-dimensional motion of a particle. Is it correct to say from that the graph the particles moves in a straight line for t is less than 0 and on a particular path for t is greater than 0? If not, you suggest a suitable physical context of this graph. So graph will be representing like this. So physics is very well known for numerical, and that you also have to know about it. Be practice it. Now the another one we'll talk about here is that a police van moving on a highway with a speed of 30 km per hour fires a bullet at a thief car speeding away in the same direction with a speed of 192 km per hour. If the muzzle speed of the bullet is 150 meters second inverse, so with what speed does the bullet hit the thief car? You have to note that obtain that speed which is relevant for damaging the thief's car here. And the question is 19th question. You have to suggest a suitable physical situation for each of the following graphs here. So the graph we have here, so it will be, so here we go A, this is B, this is to time. So for the same we go for it, and that the another graph we have here is being as follows. So the respect to t and let us be. So here the another graph is, which is in the form. Now for the another graph we have here is that is all about figure 3.23 that we'll discuss here, is that gives xt plot for the particle executing one dimension simple harmonic motion. You will learn about the motion in the detail about in the next chapters that we'll discuss. Give the sign of position, velocity and acceleration variable of the particles at t equals to 0.3 seconds, 1.2 seconds and minus 1.2 seconds. So we go for the graph here first. The graph we have 0, -1, -2. So it will be coming from -2, it will go for -1, then it will go for here, then yeah, further it will be 1. This is we have the another courtesy 2, 3, 4, 5, 6 and so on with respect to time. Okay, so this is what you have to find out. Another question we have gives the xt plot of a particle in a one dimension motion, three different equal intervals of time that are shown, in which interval which is the average speed greatest and in which is the least. Give the sign of average velocity for each interval here. So that what we'll have to go for it. Respect to t, it will be, so here this is for 3, this is bar for 2, this is bar for 1. So here for the another one we'll discuss about it, which is the another important question. Here you have a speed time graph where a particle is in motion along a constant direction, three equal intervals of time that will shown, and in which interval in the average acceleration that is greatest to the magnitude, and in which interval the average speed greatest, choosing the positive direction as a constant directions of motion that gives the sign up of v and a in the three intervals. What are the acceleration at the point a, b, c and d? So for that we'll be having to talk about it. So here we have a graph for the same. The graph we have, this is for 1, this is the speed. So here this is will be for 2, this is for 3. Okay, so this one we have here. Now we talk about for the another question that we'll be discussing in the next coming class, which is being the 25th class of the session, and hopefully in that we'll discuss about the additional exercises, questions, and then your appendings of elements of calculus. If it has been we have a time, then we'll be surely discussing for among that as well. But from here it will be ending it up. Other than this, physics we had done your chemistry part 1 and chemistry part 2 we are dealing. In the same way we are dealing with a quantitative aptitude, where we had started with arithmetical ability, in that we are in 17th topic. We had done your 16th topic as well in terms of it, and coming towards your reasoning here. Reasoning we had completed, that is your verbal reasoning and the non-verbal reasoning. Coming towards physics here, where in that we had done your first unit, that is your physical world. In physical world, which we had done your what is physics, and scope and excitement of physics, technology and society, fundamental forces in nature and nature of physical law. Then another one is your chapter 2, which is your units and measurement, that we have to cover up the introduction, the international system of units, measurement of length, measurement of mass, measurement of time, accuracy, precisions and instruments and errors in measurement, significant figures, if dimensions of physical quantities, dimension formula and the dimensional equation, dimensional analysis and its application. Unit third is your motion in a straight line, which is introduction, position, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematic, equation for the uniformly accelerated motion and the kinetic relative velocity. Chapter 4 is your motion in a plane. Then we'll be covering about chapter 5, laws of motion. Chapter 6 is work, energy and power. Chapter 7 is system of particles and rotational motion. And chapter 8 is your gravitation. That what we'll have to cover up here. So thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.